Welcome back. So, today we are peeling back the curtain on artificial intelligence. And what we're going to find isn't some black box full of magic. Nope. It's actually some surprisingly intuitive math. The math that gives a machine the power to deal with something we humans handle every single second: uncertainty.
I mean, think about it. This is the big question, right? If we want an AI to do anything useful, like filter our spam emails or drive a car, it can't just throw its hands up and quit when things aren't perfectly clear. It absolutely needs a way to think about what's probably going on.
And let's be real, our world is just a giant soup of maybes. Is it going to rain later? Is my favorite team going to win this weekend? Our lives and all the data we feed into these AI systems are just packed with this kind of uncertainty. The world is not a clean spreadsheet of ones and zeros. It is messy.
And that right there is where probability steps in. This isn't just some boring chapter in a math book you forgot about. For anyone building AI, probability is the actual language we use to describe all that uncertainty. It's how we teach a machine to stop following rigid rules and start making smart, educated guesses. A lot like we do. Okay, so how does an AI even begin to get a handle on all these maybes? Well, before it can predict anything, it needs a guide. It needs a map of all the things that could happen, and more importantly, how likely each of those things is.
And we call that map a probability distribution. Just think of it as the complete travel guide for any random event. It doesn't just list the destinations, what could happen. It tells the AI exactly how the total 100% chance is shared between all of those possibilities.
Now, these maps of chance really come in two main flavors. First, you've got discrete variables. These are for things you can count, like how many times did I get heads? It can be 0, 1, 2, or 3. That's it. Then you have continuous variables for things you measure, like the temperature outside, which could be any number in a huge range. A really solid AI has to be able to work with both. Let's look at the classic example, a fair six-sided die. Here, the probability distribution is totally flat. Every single side, 1 through 6, has the exact same shot of landing face up, about 16.7%. For an AI, this is the perfect starting point. It's a clean, baseline map where nothing is more likely than anything else.
So the AI has its map. It knows the odds. But here's where it gets really cool. That map isn't set in stone. The really amazing part is how the AI can update that map when it gets new information. This is how an AI goes from just knowing the chances to actually learning.
I love this analogy. Think of it like this. A traditional machine learning model is like a baker who follows a recipe perfectly, no matter what. But a Bayesian model, that's like a skilled chef. The chef starts with the recipe, that's their prior knowledge, but then they taste the batter, they feel the heat of the oven, and they adjust things as they go based on new evidence. It's this dynamic, adaptive way of thinking. And this whole learning process is driven by something called Bayes' theorem, which sounds complicated, but the logic is actually super simple. You start with a hunch, a prior belief. Then you see some new data, some evidence, and you use that evidence to form a new, smarter belief. This simple loop, prior belief, evidence, updated belief, is literally the mathematical formula for learning from experience. Now, this isn't just some abstract theory we talk about in a lab. This way of thinking is what powers some of the most mind-blowing AI you use every single day. Let's dig into how this language of maybe creates that wow factor we all see. Let's start with the big one, the one that's everywhere right now, generative AI. The models that create text, images, and all that. You might have heard them called stochastic parrots. And honestly, that name is spot on because it gets right to the heart of what's happening. Okay, this is so important to get. When you type "the cat sat on the AI isn't picturing a cat. It's not thinking at all. It's just a massive probability engine. It looks at all the text it's ever been trained on and calculates the odds for what word comes next. Matt might have an 85% chance. Refrigerator might have a 0.001% chance. All of its so-called creativity is really just it picking from that list of possibilities. It's all just math. Okay, moving on. Let's talk about something we've all felt. That kind of creepy way Netflix or Spotify just knows what you want to see or hear next. Well, it's not magic. It's a straight-up application of probability. So what's happening behind the scenes is something called conditional probability. The system isn't just saying, oh, this movie's popular. It's asking a much smarter question. It's asking, what is the probability that you will like Inception, given the fact that you already watched and liked Interstellar? And once that probability number gets high enough, boom, it shows up on your home screen. Now let's talk about a really high-stakes game. A self-driving car has to live in a world of constant, messy, and let's face it, potentially dangerous uncertainty. Its sensors are never going to be perfect. GPS drifts, cameras get blinded by rain. It's a tough job. So to deal with all that noise, these cars use a really clever tool called a Kalman filter. The best way to think about it is as a system for blending two uncertain guesses together. The car's internal model makes a prediction, a probability map of where it should be. The sensors give it another map of where they think it is. The Kalman filter's job is to brilliantly merge those two fuzzy pictures into one single, high-confidence, best guess of where the car actually is. That's how it stays so stable, even when the data is messy.
So when you put it all together, you can see how these concepts are the building blocks for incredible features. Bayes' theorem? That's what lets your spam filter learn and get smarter. Those probability distributions, that's how a system on a factory floor spots a weird vibration that doesn't fit the pattern. And sampling from those distributions, that's the secret sauce that gives generative AI its creative spark.
At the end of the day, this is the real takeaway. Probability is what allows the machine to graduate from just following rigid computer-like rules to something that feels a lot more like human intuition. It's the entire framework that lets an AI say, look, I'm not 100% certain, but based on everything I've seen, here are the odds. And that is a massive, massive leap. And that, of course, leaves us with a much bigger question to chew on. We've built these incredible machines that can reason with uncertainty. But if this mathematical intuition is their foundation, what are the limits? What parts of our own intelligence, our own consciousness, can't be boiled down to just calculating the odds? It's something to think about. Thanks for tuning in.